spherical embedding.
So those are classes of spherical embeddings of the homotopy. Or not? Well, is it homotopy anymore, or is it higher homotopy? Have we not defined that yet?
I think it's pointed homotopy. Because we're in H top star.
Okay. Okay, very good. Okay, yeah.
Alright, and then theorem says that pi naught of x is a pointed set.
Yeah, I mean, but intuitively what we're saying is that the nth homotopy group is, like, the first homotopy group is about mappings of circles into the space. The second homotopy group has to do with mappings of spheres into the space, and then 3 spheres, and then 4 spheres, 5 spheres, and so on, and those are capturing more and more and more exotic kinds of holes in the space, so to speak, right? I mean, okay.
You're right. That's exactly. Sorry. And so, yeah, so like I was saying, for every space, for every pointed space, pi naught of x is a pointed space, is a pointed set. Which really tells you how many different path components there are. And pi n of x is a group. I certainly hope so. Okay, so it says that the result is immediate from for the second part. The first part, let's see. So it's S naught. So pi 1x. This definition coincides with the definition that we gave in chapter 1, where the base point is the path component containing the base point of x. And then for the fact that it's a group, comes from corollary 11.17, which says that Sn is a cogroup, and 11.4 star, which
This one Nathan said was important.
the one that said it's important, and the one that says that kind of turns the cogroup into, or it's one's a cogroup if only if its dual is a group. And so that's pretty much exactly what we want. Okay. I didn't. Well,
It's like, oh, isn't that convenient? I mean, it's the whole point of this chapter is to have this paragraph.
yeah. It's for it to just be this tiny little paragraph, yeah.
So the reason we were doing everything we were doing today is to prove, in fact, that the...
Yeah.
Or to indicate where you'd find the proof, I should say.
Yeah. Okay, I don't think the 11.19 is super important. Because I guess we'll get back to it. But we do have these theorems. So that pi n of x is equal to pi n minus k. So it kind of trades out with the loop space of x, where omega k is the composite of omega k times.
Curses, what was that omega?
It's the loop space, so it's like all the mappings of loops into.
Oh. Okay. Ah.
Okay, and if we kind of continue this process all the way down to 1, we get pi. Oops. That's not pi. Okay, pi n of x is equal to pi 1 of minus 1 x for n greater than or equal to 2. That's why these loop spaces are important.
There you go. That's something kind of more, to me that, what this theorem is saying is giving sort of a more direct
Definition.
geometric
Okay.
idea of what on earth the nth homotopy group is.
Although I'm not sure if I really understand what the repeated loop space really means. It's kind of...
Oh, see, I was thinking it was just n minus, oh, so it's not, oh, I guess, I see. I was thinking it was n minus 1 loops, but that's not. It's loops of 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 loops, and the fundamental group of that at the end of it all.
Right. So it's still not very simple.
Fine, you got me.
Okay, then, corollary.
I give up on my intuition. I'll accept. I have to accept it's all formal nonsense.
Corollary.
Accept my fate.
Set pi n of x, if x points this, is abelian.
Hmm.
For n greater than or equal to 2. That follows from the fact that the omega makes H groups, which, like I mentioned before, it actually satisfies the conditions of an H space as we define in 3.20, and in 3.20, or as we defined in chapter 3, and theorem 3.20 says that an H space, or that the fundamental group of an H space is abelian. Do you guys want me to go over what an H space is, or are we alright?
I think that's fine.
Yeah, I think look back for me too. Let's see. Point is, it's abelian. Then we also have a general dimension axiom. Theorem 1.22. Is that if x is a singleton? Then pi n of x is equal to 0 for all n greater than 0. Okay, and because there would only be one function from Sn into x,
Yeah.
and so that makes it, makes it 0. Let's see. I guess it'd be fixing that. Okay. Kind of goes
Oh, and
through-
now in the next couple pages, he's going to quote unquote describe the down to earth version of it. Yeah. So I guess you could start there next time.
Good. Depending on how far you guys want to go in this chapter, obviously can't cover everything.
I'll pick your favorite part for the next meeting. And we'll
I
get
did.
it over here too.
I did pick my favorite part. No, I can. Yeah, I'll look at the rest of it and figure out what.
I think the hop vibrations are probably worth
Okay.
trying to understand a little bit about.
Yeah. I could just like run through a bunch of the theorems about the homotopy groups that kind of are extensions of what we had for the fundamental group.
Yeah, I guess I would say
Like, what time is it?
start by trying to say the intuition of the next 2 or 3 pages,
Okay.
and then kind of go from there.
Yeah, I can do that next time.
And then hopefully next Thursday I can start on the cohomology.
Are you planning on meeting other times after Thursday?
Yeah.
Okay. Makes sense.
Yeah, I will not be able to finish cohomology in a day.
What?
I have a pretty tight final week schedule, so
So if you send it to me, I will try to work around it.
Yeah, I'll send you mine too.
Yeah, that'd be good.
I feel like Monday is reading day, which I feel like is